Welcome to The Explainer. I am so glad you're here. For centuries, we looked up at the night sky and kind of just assumed we were seeing the whole picture. But the truth? The truth is so much cooler. Today, we're diving into how a completely new generation of mind-bending advanced cosmic observatories isn't just snapping pretty pictures of space, they're literally rewriting reality as we know it. Let's jump right in. What if we are completely blind? Okay, I know that sounds a little dramatic, but seriously, I want you to challenge this core assumption we all have. We think our eyes, or even our traditional telescopes, catch everything going on up there. We trust our vision implicitly, right? But in the grand cosmic scheme of things, our natural sight is actually incredibly limited. See, our eyes and the classic telescopes we've relied on for decades, they run entirely on visible light. But as we know, visible light is just this tiny, narrow sliver of the actual reality out there. It's what we call the cosmic blind spot. It's kind of like trying to comprehend the entire vastness of the universe while peeking through a tiny keyhole. Now, what's really interesting about this slide is that the universe isn't some quiet, peaceful place. It is absolutely screaming in these chaotic, invisible frequencies. We've got dark matter actively pulling whole galaxies apart, black holes literally violently warping time itself, and the actual ashes of the very first stars just floating around in invisible radiation. No way you're catching any of that with the naked eye. To see the invisible, well, we need new eyes. So here's our mission briefing to solve this blind spot. We're going to start by expanding our visible view, then we'll shift into the infrared spectrum to see through cosmic dust. After that, we'll crank the energy way up to look at X-rays and extreme cosmic violence. And finally, we'll wrap up by asking why we even look up in the first place. All right, Section 1, expanding the visible view. For decades, NASA's Hubble Space Telescope has given us those incredibly iconic space shots. But Hubble had a pretty big limitation. It essentially looked at the universe through a cosmic straw. Imagine you're trying to photograph a beach. Hubble gives you a breathtaking, super high-res picture of a single grain of sand. China's new X-10 space telescope, though, it captures the entire coastline in the exact same amount of time. We are talking about a staggering 300 times field of view upgrade, all powered by this massive 2.5 billion pixel camera. And you might wonder, why do we need to capture so much sky at once? Well, Suntian has a very specific job. It's mapping dark matter and dark energy across the cosmos, so we can figure out exactly how our universe is expanding. You just can't map the universe looking through a straw. You need the big picture. But Suntian isn't just powerful, it's actually incredibly practical. Instead of floating way out of reach, it flies right alongside China's Tiangong space station. So if it runs low on fuel or needs a camera tweak, astronauts don't have to launch some wildly expensive dedicated rescue mission. They can literally just grab the telescope, physically pull it into the station, fix it up, and pop it back out. It's a totally genius modular setup. Moving on to Section 2, infrared, seeing through dust. Unlike our human eyes, the James Webb Space Telescope, or JWST, is hunting for infrared light. And infrared basically acts as a heat signature. Out in the freezing cold vacuum of space, anything that generates heat, like a brand new baby star, is going to glow super brightly in the infrared spectrum, even if it's completely 100% pitch black in visible light. Here's the science of how it works. Visible light has these short wavelengths, right? Which means it constantly crashes into cosmic dust clouds and gets blocked. It's exactly like trying to shine a flashlight through a super thick fog. But infrared light, it has longer wavelengths, so it effortlessly cuts right through those dense dust clouds. Think of it just like a medical X-ray cutting right through your skin to reveal the bones underneath. By switching our eyes to infrared, JWST peels back the cosmic dust to reveal these glowing baby stars hidden deep inside those stellar nurseries. And because infrared light lets us peer so incredibly far into the deep universe, it basically turns us into time travelers. Light takes time to travel across space, right? So when JWST catches infrared light from the most distant galaxies, it's actually capturing light that left those stars 13.5 billion years ago. Crazy, right? We are literally looking at the universe as it was just a tiny fraction of a second after the Big Bang. And NASA isn't stopping with JWST. They're already prepping the Nancy Grace Roman Space Telescope. Think about it like this. If JWST gives us that deep, targeted infrared vision to look back at the dawn of time, the Roman telescope brings that panoramic, wide-angle power we saw with Xuntian, but applies it to the infrared spectrum. By combining wide views with infrared heat detection, its main gig is to hunt down thousands of brand new exoplanets hiding right in our own galactic backyard. All right, Section 3, X-rays, extreme cosmic violence. So far, we've been talking about the gentle, glowing heat of baby stars. But let's be real, the universe is also an incredibly chaotic, destructive place. What happens when a giant star detonates, or when a black hole violently rips a planet to shreds? They definitely don't emit gentle heat. As matter gets accelerated to millions of miles an hour and heated to extreme temperatures, these events blast out incredibly high-energy X-rays and gamma rays all across the galaxy. To actually see these events, we need eyes built to investigate what are essentially cosmic crime scenes. We're talking exploding stars, supernovae. We're talking black holes absolutely shredding planets, extreme magnetic fields whipping around pulsars, and the superheated debris from dead stars flying through space at millions of miles per hour. Visible light and infrared, they won't show you anywhere near the true intensity of this stuff. You need high-energy X-ray vision to detect the literal screams of matter being destroyed. And to catch these violent events, we rely on some highly specialized tools. The Chandra X-ray Observatory, for instance, is custom-built to stare straight into these violent events and track that superheated dead star debris. Meanwhile, the IXPE satellite looks exclusively at the extreme, twisted magnetic fields generated by these high-energy phenomena. These guys are basically the specialized detectives of our cosmic observatories. Which brings us to Section 4, Why We Look Up. The answer to why we invest billions of dollars into all this begins with a pretty profound realization. We aren't just looking anymore, we're listening. As we push the absolute boundaries of physics, the most mind-bending observatories we're building today don't even rely on capturing light at all. Instead, they rely on gravitational waves. Now, these are literal ripples in the fabric of space-time itself. Imagine two massive black holes colliding. The impact is so unimaginably severe that it sends physical waves through space, much like tossing a huge stone into a quiet pond. Using massive laser observatories down here on Earth, and eventually future ones out in deep space, we can actually detect these ripples. For the first time in human history, we aren't just watching the universe, we're listening to its heartbeat. And that right there brings us to the core of why this all matters. Every single time we build a new eye, whether it's looking in visible light, cutting through dust with infrared, catching X-rays, or feeling the literal ripples of gravity, we discover something that completely upends our understanding of physics. We build these massive machines to answer the ultimate questions. Where did we come from? Are we alone? And how will the universe end? The darkness of space is finally fading, revealing a reality that is so much more beautiful and chaotic than we ever could have imagined. So I want to leave you with this final, incredibly powerful thought to ponder. As these new eyes open and peer deeper into the cosmos than ever before, where did we come from? And are we alone? We are genuinely living in the golden age of astronomy. And the answers to those questions, they might literally be sitting in a stream of data floating down to Earth right now. Keep your eyes open and keep looking up. I hope this explainer sparked your curiosity, and I absolutely can't wait to explore more fascinating topics with you next time.